The greater the cross-sectional area, the higher the resistance.
Now being recorded.
Okay, firstly, greater cross-sectional area, higher reading of ammeter. Okay, greater cross-sectional, higher ammeter. Okay. And then as for the second one, Ivy's answer is greater the cross-sectional area, the higher the resistance. Sectional area, higher resistance. Okay. So, did anybody have anything to say with this answer? Do you agree with Ivy's answer? Sarah. Sarah, do you agree with Ivy's answer for B2? Yes. The greater the cross-sectional area, the higher the resistance. The greater the cross-sectional area, the higher the reading of ammeter. Sarah agree with Ivy's answer for both, is it? For both of the answer. For answer number 1 and answer number 2. Okay. So let's look at the second answer. The greater the cross-sectional area, the higher the resistance. So is this statement correct? Why is the ammeter reading higher when the cross sectional area is greater? Okay, Shneha? Yes. When the greater the cross-sectional area, the resistance is lower. Okay. Therefore, due to the low resistance, that is why we get higher reading of ammeter. Okay, due to the low resistance, the current flow is bigger. Okay, so the first one for B2, greater cross-sectional area, higher ammeter reading. Okay, so that is correct. And then for number 2, greater cross-sectional area, lower resistance. Okay, so very good. Good try, Ivy. So let's look at C. C.
Sure, I'll answer because it's not didn't answer.
Shreya, answer.
Yeah, sure, answer.
Okay. Uh, so JC will answer the next question. Okay, so C.
Sure, can I use my mic?
Yes, much easier. 5 marks.
When the vendor graph generator is switched on, plate X is positively charged.
Okay.
So the second point is electrical force is produced.
Okay.
The third point is the ping pong ball is attracted to the touch plate X. The fourth point is the surface of the ping pong ball is positively charged. And the last one is the charges repel and the ping pong ball swings to plate Y.
Okay. So 5 points. The first point is when the Venn diagram generator is switched on, okay, there will be a friction between the cable and the dome. So the plate will be positively charged. As you can see here, we have positive charge. So as we switch on, and the X plate is connected to the dome. Okay, so that is the first mark. Okay, I repeat, when the Van der Graaf generator is switched on, the plate X will be positively charged. Okay, and then for the next point, okay, so when the ping pong ball touches plate X, so in order for the ping pong ball to oscillate, it need to touch one plate. So the plate that it need to touch is the X plate. So the second point is when the ping pong ball touches the X plate, it will be uh, positively charged. Okay, so it will be positively charged. And then the third one, electrical force is produced. Sorry, the third one, electrical force is produced. The fourth point, uh, same charge will repel. So the fourth point, you need to explain that the ping pong ball will be repelled from the surface of the plate X. Okay, because they have same charge. Then lastly, uh, ping pong ball will swing to plate Y, and uh, electron will enter the ping pong ball, and the ping pong ball will become neutral. Okay, so one, and the graph, each one, the X is positively charged. Okay, on the two. So for the electrical force, you can write as the second point or the third point. So let's say we say electrical force produced. Okay. And then as for the third point, when the ping pong ball touches the X, ping pong touch X, it will be positively charged. Okay. And then the third point, uh, similar charge repel. So you can write the ping pong ball is repelled from plate X due to same charge, or like charge repel, similar charge repel. Okay, so as ping pong ball touch plate Y, electron from the earth will enter ping pong ball. Okay, the last point, electron from earth enter ping pong ball. Okay, so 5 points. And actually, the 6 point, the ping pong ball will become natural and will be released from plate Y. Sorry. Okay, so as for D, just now JC's name came out then. So JC, is JC here? JC is not here. Okay, so
Sure, I'll answer, sir.
okay, siapa tu? Siapa yang cakap tu?
Neha, sir.
Ah, oh, you are going to answer D also.
Yeah, sir.
Okay. So as for D, we have a USB power bank, and we are to modify the power bank so it can recharge the phone more efficiently and convenient to bring along. Okay, so let's discuss the answer. Okay, what is your answer?
For the number one, the density is lower so
Okay,
that the power bank is lighter and can be carried easily.
okay, so lighter. Okay, density lower so that it will be lighter. Number two.
Number two is the capacity is higher,
Mm-hmm.
so able to supply more power and can be used for a longer time.
Okay, so we need higher capacity so that we can apa tadi? What
Used
is
for a
going to
longer time, sir.
can be used for a longer time. Okay. And then as for the charging time,
Shorter charging time, it
mm-hmm.
able to save more time.
Okay, so we need shorter charging time so that we can save time lah, save time. And then as for the rate of power loss,
Lower, able to save more energy.
okay, so we need to have a lower power loss so that it's more efficient and able to save more energy. And number of USB port,
Higher number, able to recharge more devices at once.
okay, so we want higher USB can charge more. Okay, as for the rate of power loss, tadi I sebut efficient kan. So we cannot use efficient because efficient is in the question. So save energy. Okay, so that is the answer for question D. So this is essay question. So D, density of power bank, we need lower density so that it will be lighter, easier to carry. Okay, and then the capacity of the electrical charge of the power bank, we need a higher capacity so it can be charged more and can be used longer time. Okay, and as for the charging time, we need shorter charging time, so save time. We can use it more frequently. Okay, the rate of power loss is low, so that we can save energy. We cannot use efficient as our answer because it is already in the question. And number of USB port is high, so that we can charge more phone. Okay, very good. So let's continue with question 2. Just now, Abby's name came out. So Abby, can you please answer question A? Okay, question A. The meaning of electric field, region around a charged particle where any electric charge in the region will experience electric force. Okay, so that is the definition of electric field. And what about A2?
Teacher,
4
can you
marks.
explain me?
Mm-hmm.
So first, the polystyrene ball will be attracted towards the left side of the metal plate,
Mm-hmm.
and
Left
then
side.
the metal plate will become positively charged when it's switched on,
Okay.
and then the polystyrene ball will recharge by the positively charged metal plate,
Mm-hmm.
and
So
then it
this
will
is
be attracted.
your answer is you have given 2 points. Okay, number one, when it is switched on, the plate will be positively charged, and then number two, when the polystyrene ball touch metal plate X, it will be positively charged. Okay, so 2 points. So the third point,
And then when the ball and then when the polystyrene ball touches the metal Y, it will become negatively charged,
mm-hmm.
and then the the process will be repeated and the ball will oscillate to and fro between the metal plate X and Y.
Okay, so 4 marks. Well, actually, the answer we can get more than 4 marks. Okay, so firstly, Abby said that when the plate is switched on, it will be positively charged. So that is the first point. And then the second point is when the ball touches plate X, it will become positively charged. Okay, so that is the second point. And the third point, same charge will repel. So, or you can say that the ping pong ball will be repelled from plate X, and then point 4, uh, when it is repelled, it will touch plate Y and will become negatively charged. Okay, so point 5, same charge will repel, and point 6, the ping pong ball will be oscillating back and forth between plate X and plate Y. Okay, so any of the 6 points you can get marked for the A2. Okay, so now as for uh, B, so is Nikita here? Hari ni tak ramai eh? Kenapa ya? Okay, Nikita is not here. Okay, so Jasmine, please answer question B. Okay, 5 marks. Relate current with effective resistance. Compare voltage, current, and effective resistance, and relate effective resistance with relate current with effective resistance, and make a conclusion relationship between current and brightness of the bulb. Okay, 5 marks. So Jasmine, what is your answer for B? You can switch on your mic, or you can write the answer on the chat area. Yes, Jasmine? Okay, voltage supply of 10.2 and 10.3 is the same. Why do you say that the voltage supply is the same? How do we know that the voltage supply is the same? Which part do you refer to? Okay, the number of battery. Both diagram has 3 number of battery arranged in series. Okay, so the next one, as for the current, okay, as for the current, 10.3 is bigger compared to 10.2. Okay, so we can refer to the diagram itself. And the third one is the effective resistance. Okay, the effective resistance 10.3 is less than 10.2. So why do you say that 10.3 is less than 10.2? Which part do you refer to? So which part do you refer to in order for us to determine which one has lower effective resistance? What are we referring to? Okay, arrangement of the resistance. Okay, so 10.3 the arrangement is in parallel, whereas 10.2 the arrangement is in series. So series arrangement, the total or the effective resistance is we add up both resistance, whereas for parallel arrangement it will be 1 over R. Okay, and then for the fourth point, relate current and effective resistance. Okay, higher current, lower effective resistance. I should be the other way around, because effective resistance is the manipulated. Okay, the current is the responding. Okay, so the the best answer is we write the manipulated first, then the responding. So lower effective resistance, higher current. But if your answer is higher current, lower resistance, also you still get mark. Okay, you won't be penalized with the wrong arrangement. Ini bukan eksperimen. Okay, so the last one, relationship between current and brightness of the bulb. Okay, higher current, higher brightness. Okay, as the current increases, the brightness of the bulb increases. Okay, very good. So now, so let's continue with I don't think Dhanushini is here. Ada ke Dhanushini? Tak ada. So, okay. So, Yoshini. Is Yoshini here? Yes. Yoshini, please give the answer for D. We have an electrical kettle. For we are to modify the suitable equipment to design electric kettle that can boil water faster and safe. So boil water faster and safe. Your answer may include aspects like resistivity of the immersion heater, specific heat capacity of the kettle body, and others. Okay, so Yoshiri, higher resistivity produce heat easily. Okay. Uh, Number 2, longer length of immersion heater, higher resistance. Okay, very good. Number 3, lower specific capacity, easily heats up. Yes. Okay, the thermistor sensor switch off automatically after boil. Okay, thermistor is a sensor that sense difference in temperature. So it will switch off automatically when it reach certain temperature. And number 5, higher power of immersion heater produce more energy. Okay, when we have higher power, it will produce more energy. In this sense, is heat energy. Okay, so I repeat, higher resistivity produce heat easily or produce more heat. Longer length of immersion heater have higher resistance. So when it resistance is higher, heat produced is more. Lower specific capacity become hot faster or hot easier. Thermistor sensor. So thermistor sensor is a sensor that will switch off as it reach a certain temperature. Okay, high power of immersion heater produce more energy or produce more heat. Okay, very good. So now let's continue with the next question. Question for section, this one is question section B. Okay, so Kasih, please give the answer for SPM 2009, question 1A and B. Okay, B ada B1, ada B2. So what is the meaning of potential difference? Kasih. Okay, amount of work done to move one unit of electrical charge from one point to another. Okay, very good. So that is the definition of potential difference, work done to move 1 unit or 1 coulomb charge from one point to another. And B, we have a potential difference against time against current graph. So based on the graph, state the relationship between V and I, and what can you conclude about the resistance of the lamp, and give reason for your answer. Okay, so 3 points that we need to uh, tackle. So based on the graph, what is the relationship? Inversely proportional, rate increase of voltage increase, resistance increase. Okay. Um, for your answer, your first part of the answer, you need is not accurate. Okay, this is not an inversely proportional graph. Inversely proportional graph would be like this. This is an inversely proportional graph. Inversely meaning that when y increases, x decreases. But this graph, x increase, y also increase. It's just that it is not linearly. So this graph is not linearly proportional. Kalau linearly proportional, it will be like this. Okay, so the correct answer is your second part. Yes, when V increase, current increase. So just give a general answer, because potential difference does not increase linearly with current. So we shouldn't answer linear. Okay, so our answer is potential difference increases with current, or when potential difference increase, current increases. Okay, so number 2, what can you conclude about the resistance of the lamp? Or from where can we conclude the resistance of the lamp based on the graph? This is a voltage against current graph. So from where can we, yes, okay. So for the second one, what can we conclude about the resistance of the lamp? So we should base on the gradient. So referring to the gradient of the graph, what can you say about the resistance? Increase, decrease. Tengok saya punya graph. Look at the gradient. As current increase, what happened to the gradient? Yes, okay. So if you look at the graph, as the current increase, okay, if you look at my gradient, nampak dia makin curam. So the gradient is higher. So what can you conclude about resistance of the lamp? As current increase, resistance increases. Okay, last one. Give one answer. Give one reason for your answer. Why do you say that when current increase, resistance increase? Okay. How do we conclude that the when resistance increase are increase? From where? The reason, you already answered the reason. Can somebody help, Kasih? Give one reason for your answer. How do we conclude that the resistance increase with current? Suta. Well, actually the answer, yes, okay. As the current increase, the gradient increases. That is the reason why we conclude the relationship between current and resistance. Okay, reason of our answer is when current increase, the gradient increase. Okay, so that is the answer for B1. Okay, Kasih, what about B2? What happened to the energy dissipated in filament lamp when the current flowing is decreased? When current decrease, what happened to the energy dissipated, or what happened to the heat release? Yes, Kasih? Yes. Okay. So when the current flow decrease, the energy dissipated from the filament will also decrease. Energy dissipated is the heat release. Okay. So when the current flow decrease, the heat release will also decrease, because as the current decrease, resistance will decrease. Therefore, heat release will also decrease. Okay. So C. Okay, so is Satana here? Tak ada. Hari ni kenapa ramai yang tak ada? Okay, sudah. Uh, what is the answer for C? You are to calculate current, you are to calculate heat energy loss, and also the efficiency of the bulb. Okay, you are given. Okay, for number 1, as for the current, we use formula P equals to VI, and the current is 0.05 ampere. Okay, and as for number 2, okay, what about the heat loss? Okay, so we use E equals to VIP. So the energy loss is 1 joule. Okay, very good. And lastly, the efficiency of the bulb. Okay, efficiency of the bulb is 91.67%. So what is the output power? Output power, input power dia berapa? Input power is 11 watt. Output power 12. Hai, mana boleh output power lagi besar daripada input? Okay, output power berapa? Check again. Output power. Input power already given 11 watt. So what is the output power? So 11 joule per second of light energy is produced. And we already calculated heat energy loss in 1 second is 1 joule. So energy loss, power loss in 1 second would be? Yeah, energy loss 1 second 1 joule. Energy power loss in 1 second would be? 1 watt. Okay, so since the power loss is 1 watt, what would be the output power? Yes, 10 watt. And the input power is 11 times 100. So what do you get the efficiency? 10 divided by 11 times 100. What do we get? Dapat 91.67 ke? 90.91. Okay, so the current flow, we use P equals to IV. So we get current flow as 0.05 ampere. Okay, and then the heat loss, I prefer for heat loss, we use I square R. Tapi R ada ke? Okay, R tak ada. So kita boleh guna any other formula used to calculate energy. Sebab kita dah diberi the light energy 11 joule per second. So you use BIV. Okay, so kita boleh dapat 1 joule. This one is for 1 second, 1 joule energy loss. And if it is for power, times 1 second lah. So you get 1 watt. So since this is lost, 1 watt is lost. So the efficiency of the bulb is power output minus divided by power input times 100. So since 1 watt is lost, so the power output only 10 watt left, divided by 11 times 100. Okay. Okay. So okay, Jazin. Question D. For question D, we are given. Jazin ada kan? Jazin pun tak ada ke? Ada. Okay. So, we are given 5 elements and we need to choose characteristic that will produce brightest light. So, what is your answer, Yazin? Okay, so we are given characteristic. Okay, firstly, for the tungsten wire or the copper wire, we are given the type of wire. Okay, one is either copper wire or tungsten wire. Okay, so you need to choose which wire is better. Okay, and why. And then as for the second one is the thickness of the wire. Okay, whether we need to use a thinner wire or thicker wire, and then why. And then the type of wire, is the wire coiled or the wire not coiled. So which one is better, coiled wire or not coiled wire? Okay, and then lastly is the gas inside the bulb. Should we use low pressure or high pressure? So maybe you can try with the type of wire first. Yes, which one do you think is best? Copper or tungsten? Copper. Why do you choose copper? Kalau copper, why do you choose? When you answer, you need to give your justification. So why do you choose copper? Can anybody help Jessie? So this is, as I've told you before, this is a filament bulb, a filament bulb. Okay, for filament bulb, when the current flow through the wire, if the resistance is high, the current flow will be converted to heat. Bukan current flow lah, energy, electrical energy that flow through the wire will be converted to heat because the resistance is high. And then up to a certain point, when the heat is too much, it will be converted to light. Okay, so for a filament bulb, we need a high resistance wire. Okay, so that is why we choose tungsten, because tungsten has higher resistance. Okay. As for the thickness of wire, Jessie, which one do you think is the best? Should we use thick wire or thin wire? Remember, to produce light, it needs high resistance. Okay, yes, okay. So as for the thickness or thickest, the thickness of the wire, we need to use thin wire. Why thin wire? Yes, Jason, why do you choose thin wire? Yes, due to the high resistance. Okay. And then as for the coil and non-coil wire, which one do you think is the best? Coiled wire or non-coiled wire? Smaller current produced cannot, because it is not a small current produced. It is due to the high resistance that convert the electrical energy to heat. So if you say small current produced, so heat produced will be lesser. Do you get me or not? Okay. So kita tak fokus kepada small current. Resistance will cause current to become smaller lah. But power also affect the current power pula, voltage. Okay. So now if you answer small current, kalau current too small, electrical energy will be low. Yes, we can repeat our reason lebih daripada 2 kali in fact. Okay, if the reason is correct, then you can repeat your reason how many times you feel it is can be used. Okay, so as for the type of wire, we use tungsten wire because of high resistance. And as for the thickness of wire, we use thin wire because of the high resistance. Okay, and then as for the coil, do we want non-coil or coil wire? I open to anybody to answer. And please give the reason. Yes, okay. We want coiled wire because more heat produced. If the wire is coiled, then the wire is long. If it's not coiled, so dia bulb tu besar ni je kan, certain length je kan. If it's not coiled, so we are going to use a short wire. If it's coiled, we can put longer wire in that certain distance. Okay, so coiled reason more heat produced boleh, or coiled longer wire can be apa, longer wire can be used macam itulah, ataupun higher resistance of wire pun boleh juga. Okay, so we can repeat the reason 3 times. Boleh, tak ada masalah. Okay, and as for the gas, do you think we need high pressure gas or low pressure? If high pressure, Y. If low pressure, Y. Okay, low pressure carry heat away from the filament. Okay, so we need a low pressure uh, gas so that heat can be pulled out from the filament. Okay, yes, very good. And lastly, from the 5 filament, which one is the best? We choose R and repeat again the characteristic of R. Okay, so I repeat, as for the type of wire, we choose tungsten, resin, high resistant. As for the thickness, we use thin, resin, high resistant. As for the type of wire, we choose coil because high resistant or more length can be fit into the filament, or uh, more heat produced. And as for the gas, we want low pressure because it can put ataupun carry heat away from the filament. Okay, so the next question, dia menjerit lambat. Okay, Samitra, is Samitra here? Yes. Okay, Samitra, please continue with the next question.
And so can I use mic?
Yes.
An electric field is the region around a charged particle where any electric charge in the region will experience an electric force.
Okay, so region where a charge experience electric force. A2, 4 marks. So give your answer 1 point at a time.
First point, when the power supply is turned on,
Mm-hmm.
plate P will be negatively charged, whereas plate Q will be positively charged.
Okay. Second point.
The candle flame will spread out between the two metal plates.
Okay.
The third point, the spread of the flames towards plate P is greater than the plate Q.
Okay. The fourth point. Why?
The negative ions will be attracted to the positively charged metal plate, while the positive ions to the negatively charged metal plates.
Uh-huh. So the fourth point is better for you to add up why does the flame on the negative plate is bigger.
So is it because positive ions have larger mass and size compared to
Yes.
negative ions?
Yes. Okay, so your fourth point tu kurang satu je lah. So when you explain that the negative charge, charge is attracted to the positive plate and positive charge attracted to negative plate, you need to explain also the flame towards the negative plate is bigger because the mass of positive charge is bigger. Okay, so very good. So you have answered all the 4 marks. Cuba ditinggal sikit tadi yang less of the positive ion tu. Okay, so B. B, siapa lagi yang nama saya belum panggil? Is Kalpana here? Kalpana. Can you please give the answer for B? Okay, EMF is given as 2 volt and internal resistance is 1 ohm. So what would be the reading of ammeter when S1 is switched on? S1 switch on. Okay, can you please show the working for the answer? Satu markah je ni. 2 markah. So 1 mark is the working. The answer is correct, 0.33. So you need to show the working for uh, B1. How do we get 0.33 ampere? Yes, okay. So we use the formula E equals to I, capital R plus R, small r. Okay, number two. Uh, but in order for you to get the answer, is you need to substitute lah. Okay, but the formula we use is that formula. Okay, and number two, if both S1 and S2 are switched on. Okay, both switch on. What would be the reading of the emitter? Okay, 3 marks. So you need to show the working. Okay, so firstly we calculate the effective resistance. Okay, and then you calculate the current. But if we do calculation for our answer, we don't leave our answer in fraction. You need to give your answer in point form. Okay, if you leave your answer in fraction, you won't get mark for your answer. Let's say there are 3 marks, you will only get 2 marks for your working, but your answer you will not get mark, even though your answer is correct. So what is the current? Current is 0.44 ampere. Okay, very good. Okay, so firstly, for question B, since we have two parallel resistance, we need to calculate the effective resistance first. Okay, so after we get the effective resistance, then we use the formula V equals to IR. Oh, jangan lupa masukkan sekali ni 1 ampere dalam formula yang kita gunakan. This one E equals to I R plus R. Use that formula, then you get your answer. Okay, and please remember, for calculation, don't leave your answer in fraction. If you leave your answer in fraction, you will not get mark for answer. Okay, ingat because the examiner will say that you did not complete your task. Okay, so answer tak dapat markah, uji. Okay, so lastly for C, siapa lagi yang saya boleh panggil? Yushni sudah, Sneha, Sarah, Samitra, dan juga Jasmine. Who want to volunteer? For today's lesson, I'm giving you PBD mark ya. And for those who have answered, dapat sampai 5 ataupun 6 TP. And 5E, most of you get TP6 for the first first topic mechanic. Okay, most of you get 6. So this one is I'm taking marks for PVD. Okay, C. Who want to try and answer C? Okay, we have 4 circuit W, X, Y, and Z. Okay, with arrangement of battery, different arrangement. Okay, and then different arrangement for the bulb, and also the placing and the value for the resistor. Okay, so we are to determine the most suitable characteristic that can be used to light up the bulb with normal brightness. Okay, so if the question states light up bulb with normal brightness, so we must make sure that the bulb receive enough voltage. Okay, So if the bulb is, let's say here, 2 volt, so it need 2 volt. If the voltage is less than 2 volt, it will not light up in normal brightness. Okay, and then okay, you may need to do some calculation, study the specification, and then choose which one is the best. Okay, so type of connection of cell. So which type do you think is the best? Batteries arranged in series or batteries arranged in parallel? Anybody? Open. Okay, parallel voltage is higher. So do you agree with Suta's answer? Okay, battery arranged in parallel because it gives higher voltage. Which arrangement do you think will give higher voltage? Parallel or series? Yes, okay. So type of connection of cell is series. Reason it produce higher voltage. Okay. Why? Because when you arrange in series, the total voltage is V1 plus V2 plus V3. But if it's arranged in parallel, V1 equals to V2 equals to V3. Okay? So the arrangement of the cell is in series, reason give higher voltage. Okay. And then the connection of the terminal of the cell. How do we connect the terminal of the cell? Okay, should we connect positive to negative or negative to positive? Or positive to positive or negative to negative? Let's say, as for the cell terminal, okay, you connect to where? Positive terminal of the battery should be connected to positive terminal to another battery, or the positive terminal should be connected to negative terminal. Yes, okay. The connection should be positive to negative or negative to positive. Different polarity. Okay, why? As long as your answer is different polarity, then it is correct. Why? Why do we need to connect it to different polarity? Attracts, what attract? It will attract what? Charge. Okay. Um, when positive terminal is connected to negative terminal, then other charge, what happened to the charge? Yes, the charge will flow. So positive terminal connected to negative terminal of a cell, reason to complete the circuit or to allow current to flow. Okay, so for this one, connection of terminals of the cell, opposite charge will attract. For this one, the opposite charge will attract is not suitable for the answer. Okay, the best if you use current flow. Okay, allow current to flow or complete the circuit. Okay, if opposite charge attract is when you answer the ping pong ball or when you answer the candle flame. Okay, because this one is to allow charge to flow. Okay, boleh sudah? Yes. Okay, so number 3, connection between resistor and the bulb. How should we connect the resistor with the bulb? Should we connect in parallel or should we connect in series? Should the resistance be connect? Should the resistor connected to the bulb in series or in parallel? Okay, this is connection in series. This is connection in parallel. This is connect in series. This is also connect in series. So which one do you think is the best connection, in series or in parallel? Okay, so the resistor should be connect in series with the bulb. Why? We need to increase the resistance. Why? Because the cell that we use is 4.5 volt, whereas our bulb is 2 volt each. Even if we arrange it in parallel, the voltage is higher. So kalau voltage terlalu besar compared to the voltage of the bulb, it will cause the bulb to blow up. Okay, so we need to place the resistor in series with the bulb. Reason to increase resistance. Okay, lastly, should we arrange the bulb in series or in parallel? Yes, okay. The bulb should be arranged in parallel so that when one bulb does not work, the other will still function. So based on our choice of characteristic, which circuit do you think is the best that follow all our characteristics? Yes, okay. So the most suitable circuit is circuit X. Okay. So circuit X. So kita dah habis electricity. Okay. Are there any question on electricity? Ada apa-apa tak, kita dah habis and I see that you are able to calculate internal resistance, you are able to calculate the voltage, you are able to determine resistor from graph and so on. So basically we are good in electricity. Okay, so based on your answer for the exercise that I gave you, I can conclude that most of you are able to answer question related to electricity. Okay, so for our next class, we are going to go to the next topic, which is electromagnet. We still have another 4 topics. Okay, electromagnet, electronic, quantum, and also radioactive. Okay, so our next class, we are going to electromagnet. Okay, so any question? Ada apa-apa soalan tak? Okay, tak ada. Okay, so if there is no question, we stop here. So tolong baca sikit berkaitan dengan electromagnet because our next class we are going to continue with electromagnet. Okay, so with that, thank you class.